So moving on to the next part, sorry for interruption. We will go ahead, moving on to the next word, we will go ahead and remove a node from the frontier by calling the frontier.remove function and update the number of states here, and update the number of states we have explored, because now we have explored one additional set. So we say the self dot number explored plus equals 1, adding 1 to be the number of states we have explored. Once we remove a node from the frontier and recall it, the next step to see whether it's not its goal for the goal test. And in the case of the maze, the goal is pretty easy, so I check to see whether the state of the node is equal to the goal. This is the part here. So initially I set up the maze and set up its value called goal, which is the property of the maze, so I can just check it to see the node is actually the goal. And if it is the goal, that I want to backtrack my way towards figuring out the what actions I need to take, like I am figuring out or I am backtracking for this reason, because if I want to evaluate or I want to calculate the cost, so I have to backtrack, and I backtrack and measure the cost. After that I will be able to find the optimal path here. So we call so we will recall that every node stores in the parent node, and the node that came from it that we used to get this node, and also the action we used to order to get there. So moving on to the next option, I have created a loop here where I am constantly just looking for the parent of every node and keeping track all of these parents, what action I took to get them to parent to do this, and so the loop is going to keep repeating the same process, looking through all the parent nodes until we get back to the initial state, until we get back to the initial state, which is no parent, and where the node dot parent is going to equal to none. As I do, I'm going to be building up the list of all the actions what I'm following to the list of all the cells, and the part of the, and it will be our part of the solution. But here I will reverse them, because when I build it up going to the goal back to the initial state, I am building the sequence of actions from the goal from the initial state, but I want to reverse them in order to get the sequence of action from the initial state to the goal, and that is ultimately going to be my solution. So this one. So all of this happens if the current state is equal to the goal state. And otherwise, if we do not find the goal, then we will go ahead and add this state to the explore. Okay. To the explore set, to say I have explored this state. Now we need to go back to if I overcome explores the future, and then this logic here, this is the logic here, implements the idea of adding neighbors to the frontier. And I am saying, look, all the neighbors, and I implement the function called neighbors that we can use take and look at all over them, and for each of those neighbors I'm going to check if the state is already frontier, if the state is already explored or not, and if it's not either of those, then I will go ahead and view the next child node to the next node for the frontier, which is here, child finding path. So that's all. This is the images and some graphical representation part. So that was the overall main code I have just explored. That's all for today. Thank you so much for listening. Assalamu alaikum.